Here, your question is vector A given, vector B given and C also given such that vector A plus lambda vector B is perpendicular to vector C. This relation is given. So, 10th one, given vector A plus lambda vector B perpendicular to vector C, then we have to find out value of lambda. So, obviously this relation here I will use. So, though it is given perpendicular, so dot product will be 0. So, here I will get vector A, that is this value 2i cap plus 2j cap plus 3k cap plus lambda vector B minus I cap plus 2j cap plus k cap into perpendicular given, suppose A perpendicular B. How you can prove? If you are getting its dot product 0. Similarly reverse, that it is given perpendicular means we have to write its dot product equals to 0. So here your vector C is 3i cap plus j cap which is equals to 0. Now first of all here I have to find out addition of these both vectors and after that we'll do dot product with C. So now see, I component, corresponding component will be always added. So 2 minus lambda I cap plus 2 plus 2 lambda j cap plus 3 plus lambda k cap into 3i cap plus j cap equals to 0. Now dot product I have to find, so that time be careful. You have to remember that I dot I, j dot j, k dot k equals to 1. Rest of the part, that is I dot j, I dot k, k dot I, k dot j. Similarly, these all things are going to be 0. Only corresponding components product is going to be 1. So here I will multiply with this I component. So 3 into 2 minus lambda plus this is 1 only. So 2 plus 2 lambda which is equals to 0. This component is not there, so it is going to be 0 only. So now 3 2s are 6 minus 3 lambda plus 2 lambda equals to 0. So 6 plus 2 that is 8 minus lambda equals to 0. So lambda value is here 8. So lambda value we obtain here 8. Hope it is understood to you. Now 11th one here will solve. Say this 11th question. Show that this is perpendicular to this one for any two non-zero vectors A and B. So let me assume first of all, let P vector is equals to magnitude of A dot B plus magnitude of B dot A. And let me assume Q vector equals to magnitude of A dot B minus magnitude of B dot A. Here I have to show that these both are perpendicular, means I have to show. Therefore, here we have to show P dot Q is equals to 0, that is P perpendicular to Q. So first of all we'll do its dot product. So vector P dot vector Q equals to P vector is this one, magnitude of A dot B plus magnitude of B into A dot this vector magnitude of A into B minus magnitude of B vector A. Now dot product. So gradually first with this whole bracket, then the second with this whole bracket. So here A into A magnitude of A square, B into B magnitude of B square, B dot B we are knowing that magnitude of that vector square. Now the same plus minus minus. So magnitude of A, magnitude of B into A and B. Now this one plus B into magnitude of A, as we are knowing dot product is commutative. So in place of magnitude B, magnitude A, may I write down magnitude of A into magnitude of B. So A magnitude of B to A dot B plus minus minus magnitude of B that is square A dot A magnitude of A square. Now also these both are going to be cancelled 0. b square, magnitude of b square, magnitude of a square, magnitude of a square, which is equals to 0. So therefore P perpendicular to Q. So children, hope these both solutions understood to you. Thank you.